Well, here I'm going to prove to you that 3 is equal to 5, and here we go. I have that I is equals to square root of negative 1. This means that negative I is equals to negative square root of negative 1. And from here, I can split this right hand side. I can have negative 1 times square root of negative 1. And negative 1 is the same thing as saying I to the power 2, I squared, like this, alright? Times square root of negative 1. Remember, on your left hand, you have negative I, and here we just have negative I, like that. And now, I want you to know that for this I here, this blue I to the second power, I can do something to the power. I can multiply 2 to the power and divide the 2. That is, I multiply 2 right here and divide it by the 2. It's the same thing, alright? So if I multiply 2 by the power, I'm going to have I to the power 4 divided by 2. Okay, and this right here can be written as, well, I to the fourth power, I to the fourth power, and I divide everything by 2. What does that simply mean? This is the same thing as saying square root of I to the fourth power, like this, alright? Very nice. So in place of I to power 2, I'm just going to put square root of I to power 4. So I'll have square root of I to the fourth power, and remember your square root of negative 1. Okay, let's see, I'm done with this, I can just clean it up. Alright, so from here, remember it's still equal to negative I. And you know, your product of two square roots, you can actually take one of the square roots and take the product of the two numbers. So let me take it up like this. I'm going to have negative I is equal to square root of, well, here I'm just going to have I to the fourth power times here I just have negative 1, like this. Alright, very nice. And I believe you know that I to the fourth power is the same thing as saying I to the second power all squared. And well, for I being square root of negative 1, okay, I being square root of negative 1, that is I alone, so you square that and you square it again. I'm writing this in another form. So square root of negative 1 square is just negative 1. And you take this other square like this. So the square of that is just going to give us positive 1. Alright? That simply means I to the fourth power, which is all of this, is the same thing as saying positive 1. So I just put positive 1 right there. Let me clean this up. So I take in positive 1 for the place of I have the positive 1. And this is just negative 1. So I have times negative 1. And everything was under the square root sign. This is just negative I on the left hand side. And what do you see? Well, negative 1 times positive 1 is giving us negative 1. So we have negative I to become square root of negative 1. And square root of negative 1 is imaginary. So we call it I. So negative I is equals to I. Oh, wow. Well, from here, we can just say let's cancel I on both sides. We have negative 1 is equals to positive 1. And what else do you see? Well, we are almost there. This alone shows that negative 1 equals to positive 1. So if I multiply both sides by 2, I'm going to have negative 2 equals to positive 2. Multiply both sides by any number n, it shows that negative n is equals to positive n. In mathematics, this is not true. So where is the error? Oh, this is not shown. If I multiply both sides by n, I will just have right. Let me take this up. I will have negative n is equals to positive n. And in mathematics, this right here is not true. So where is the error in this solution? Well, you check that out. You find out where the error is. Actually, whether it is here, whether it is here, wherever the error be. But my concern is to show you that 3 is equal to 5. From our results like this here, let me take it up. From this result we have, I can simply show you guys that if I simply add 4 on both sides, I'm going to have 4 minus 1 on the left hand side, and on the right hand side I'll have 4 plus 1. Well, on the left hand side, I add 4 to both sides like I told you, so 4, 4. So 4 minus 1 is giving us 3, and 4 plus 1 is giving us 5. And of course, we are using equality sign, just like it is here. So we just added 4 on both sides for the sake of justice, and we have 3 equals to 5. So now you see that 3 is equal to 5. And besides, this is actually wrong in math, so where is the error? Okay,